Good afternoon, class. In this video, what I'd like to do is to go over equations 5 and 6 from the kinematic equations. So this problem will be number 24 from kinematic reflection questions equation 5. However, the tools that you use in this one can be applied equally to equation number 6. So here we go. This is number 21 for those of you who may have a hard time seeing this. Is number 21 on that homework set. So a ball rolls at 1 meter per second initially with an initial position of 0 meters and a final position of 42 meters at an acceleration of 1 meter per second squared. What is the final velocity of the ball? So what we do here is we now say, okay, there's the problem. Let us now look at all of the words and see if we can extract all of the information and all the numbers that we need to solve this. So here we go. We set it up as we would with numbers 1 through 20 in the kinematic reflection questions, equation 5. And so we have v final equals something meters per second, v initial, acceleration, x final, and x initial. And again, all the units and variables are written in black because they don't change, but the numbers that are given in the problem will change, so that's why they're written in green. So in this case, when I look at it, it says a ball rolls. Now that word rolls implies velocity. So make sure that you immediately acknowledge that one. So it rolls at 1 meter per second. So I still don't know at that point whether it's v final or v initial, but it says it rolls at 1 meter per second initially. So that's why we know it's v initial. With an initial position, so x initial, of 0 meters, and a final position or x final of 42 meters at an acceleration, so acceleration, of 1 meter per second squared. So now I'm looking for v final because it does ask me what is the final velocity of the ball. Well, I already know that this is equation 5 from kinematic reflection questions, equation 5. So it's the fifth kinematic equation. So all I do is I acknowledge that, write it down in blue. I mean, of course, again, you don't have to do this, but I like to do that for the video's sake. So I wrote down my equation, and now what I'm going to do is I'm going to substitute all of my numbers into the equation and then use order of operations to solve. So here we go. V squared is equal to v initial, which is 1 squared, plus 2 times acceleration, which is 1, times x final, 42, minus x initial, 0, and that's in parentheses. So now we can do a little review of the order of operations, or PEMDAS. So P is parentheses. That always comes first. So I have to deal with this 42 minus 0 first. 42 minus 0, which fortunately is just 42. So we don't have to do too much math there. Then we look at the exponents. 1 squared. Okay, let's deal with that. 1 squared is still 1, so that's fine. What about v squared? Well, v is a variable, and just because I square it doesn't get me any closer to solving it. So for now, I have to leave v squared exactly where it is and just move on with the next part of the order of operations. So now I have 1 plus 2 times 42. Well, I can't do addition and subtraction. That's the last part of PEMDAS. So now we're moving on to the M and D part, multiplication and division, left to right. So I look at this and go, okay, 1 can't do anything. 2 times 42 is 84. So now I can do addition and subtraction. 1 plus 84 is 85. Now that I've gotten this down to v squared equals 85, that's not the answer that I want. I want velocity, final velocity, not the square of final velocity. So what I have to do now is I have to square root v squared, because the opposite operation of squaring something is to take the square root. Or more generally, to take the whatever root of something, or to the opposite operation of raising something to whatever power. In math, we would call it like the nth power, is to take the nth root of whatever variable that is. So in this example, the v to the second power, v raised to the second power, is 85. So to find out what v is, we have to do the opposite operation of squaring it, which is taking the square root. So when I do that, I get v equals square root of 85 meters per second, just like I did using the shortcut method. Now, I do want to take this example and use this as an example of what I'm looking for, especially on a test. If you leave it as square root of 85, like so, this is a perfectly acceptable answer. I am totally fine with this. Honestly, I would prefer that it be left in this form rather than you trying to write out some non-terminating decimal that just goes on forever. I'd rather not see that. I'd rather have a whole number, a fraction, or a square root like this. I'll take a terminating decimal, but if I can avoid even that, I would. So I just want to pause to make sure you understand. This answer right here is perfectly fine. If you write this on your test, that is fine as well. So that concludes how to deal with the 5th and 6th kinematic equations. Good luck on your studies, and may the force be with you.